Hi, I'm Brian Henning. I'm here to talk about navigating the future of citizen engagement amid bot threats. So, again, I'm Brian. I'm a solutions engineer. I've been at Human for 3 years, and I've solved several bot problems, including things like scraping, SMS pumping, which I'll actually talk about today. And I also have solved things like carding attacks and ATO. And I've solved them in several different organizations. Kind of a little bit of background on me. I've served in the military. I was in the Minnesota Army National Guard for 6 years. I was a developer at Target. I worked in their supply chain area and pharmacy. And actually, that's where I got exposed to cybersecurity. I was actually there as when the Target had their breach. So I've kind of lived it firsthand on the impacts of cyber attacks. I am based out of Minneapolis, and I just enjoy solving problems. I'm not one to give up on problems, so you'll find me continuing to think about and iterate on solving these problems. And I just enjoy working with technology and understanding how it works. So today, the agenda is pretty simple, just 5 things. We're going to understand the threat, the impact it has on users, how to combat its activity, and use case. I'll give a use case example, and then we'll walk through the key takeaways. All right. First, first off, bot attacks are on the rise. This is quite alarming. You can see on the chart, scraping is up 240% year over year. Just very alarming numbers. Carding attacks, 111% increase year over year. Bots in general are up year over year, 106%. I mean, some of the key ones that are coming, you can kind of see PI harvesting, account takeovers, carding. These are all common use cases I see in many organizations. And its impact just is vast and varies. A lot of the impact is around, or I should say, a lot of the bots are going after some value on a site. I think that's a theme you'll kind of see here. Some other statistics, you know, it really is all about trust. We don't want to erode the trust of our users. So think about consumers, right? When you visit a website, if you know they're untrustworthy, are you going to come back? Well, 81% of us will not come back. We think about page abandonment, which simply means that friction on a website, so things like a CAPTCHA, will deter users from coming back. 88% of us will not come back if there's friction on a site. And then you think about breaches. Those are another case where it erodes customer trust. 89% of us feel that way. So definitely some concerning and alarming things that can prevent users from coming back to visit a site. In this section, we're going to take a deep dive into the threat. We're going to dive into how bots have evolved and where they're headed in the future. Think about, let's take even a step back from all that. What is a bot, right? I always think of bots as automation on a page in just very simple terms. And really thinking about bots is non-human activity automated on a page. Pages were meant to be interacted with just by normal humans, and bots have come in and leveraged the human behavior to gain for some gain, right? That's ultimately it. Now there are good bots like your crawlers, right? That are used and are desired, and then there are bad bots where you have bad actors, taking advantage or stealing cart or cashing out on different various value propositions on websites. I'm going to pause here for a polling question. This slide really illustrates how bots are evolving. bots are really starting to mimic human behavior more and more. You're going to see me talk about it later on, but you can easily mimic human behavior through using several different tools. The technology is getting more complicated and more human-like. Um, bots are, there's AI-driven bot networks. That's the other thing to note. Bad actors are leveraging the artificial intelligence, that latest technology to, take advantage of websites. And lastly, bots are used for cyber weapons, right? Nation states are leveraging this tooling to do as their weapon of choice, as opposed to physical warfare. Now we're seeing, and I think we're seeing this in Russia, for example, where bots are being leveraged as part of the attack versus just just physical warfare. Basic protection just isn't enough. On websites, a lot of us are seeing fire hydrants, crosswalks, buses, and stoplights. These are being asked to be solved by a lot of times real humans. This friction um, is not meant to be, you know, adding it to a website can deter users from coming back, and very easily that friction, right? Um, the use of this on websites shouldn't be an intelligence test. I think that's what I'm trying to get at. Um, so that becomes a problem, and it doesn't solve. The problem is it doesn't solve the problem. It doesn't stop the bots. It's stopping humans and preventing humans from using pages as they're intended. We also have WAF, right? WAFs are a good thing, right? Web application firewalls, and they are there to protect the site. And they do have a place in the ecosystem as part of the layered approach to protection. However, sophisticated bots are continually get past those WAFs. So we need something more. Scanners as well. Scanners may or may not be real time, and they slip up. So you do see things like PII skimming of data. Continuing on, this slide I really like because it really illustrates the bot evolution, right? From when you had your basic crawlers to script bots, where they got a little bit more advanced, but where they're executing scripts as opposed to just very simple bots. Then you have that evolution into what I'll call browser emulators. So they're trying to mimic and render JavaScript within the bot itself. Again, trying to become more human-like. And then you have the human mimicking bots, the more advanced bots using AI type behaviors and patterns. So really trying to mouse click and mouse move like a real human. And then you have the different and various server-based, sorry, you have the various based attack distribution. So initially you have it all server-based. So that's easy to detect, right? Then they've evolved to a cloud-based evolution, then a Tor-based, where it's even harder to detect. You don't know where that's coming from. And now they've gotten a lot more sophisticated. So they're using residential IP-based attacks. Why stopping bot attacks matters. It has impact on revenue. For example, we see market spend being wasted. Bots are coming on page where maybe ads or different various things are on these pages. They're filling out forms, they're viewing content, and that information is fed down to downstream systems. It just creates havoc for many organizations and creates a lot of wasted spend. It also has risk, right? So if you have bots, you're automatically at risk. There's example is brand reputation, right? We talk about the Target breach, for example. That's a great example of brand reputation and brand risk that we have. And then efficiency. And the last one, you have contaminated data. I kind of talked about it in the revenue too. They kind of all tie together, right? So you have it, problems with form fills, right? That's a big one where bots will come in. Maybe they're not even interested in that form fill, but they're using that form fill to get infiltrate to the site for different various reasons. They're filling out these forms with bogus data and causing maybe workers to take action where they normally wouldn't, and you just can't trust the data. In the next three slides, I'm going to discuss why bots are a growing risk to the public sector. First and foremost, we've kind of already talked about it, but bots are becoming more human-like. That will be discussed. I'll also talk about the increased attack on the public sector portals. You have your benefits portal, your education portals, your research and access portals, and voting. I'll also discuss fraud. First, let's hit on bots becoming more human-like. We have tools like ChatGPT out there, right? I'll show you in a video here shortly how easy it is to build this bot, any bot from with almost no effort and no training whatsoever. I mean, it's just simply typing into this AI system and it outputs the exact script that you would need to run to do the attack. Now there are so many different tools out there. You think about 5 or 10 years ago, we just talked about this on the previous slide, how advanced bots are leveraging different tooling. Residential proxies, great example. It's becoming harder and harder to detect these bots. These bots are mixed, that traffic is mixed in with real human traffic. So when you're looking to stop, a bot, you can't just look at IP address anymore. That's just not going to cut it. Also, you have CAPTCHA solvers out there and CAPTCHA solver services. These tools are are real. They have real humans working on these tools. They're solving these CAPTCHAs on behalf of the bad actor for pennies on the dollar. So if the value of the thing that they're looking for is worth more than the CAPTCHA solve, they're obviously going to do that. Device spoofing, another action that's being taken and seen, right? Bad actors, again, are trying to mimic the JavaScript, the exact behavior of some of these devices. They try to look like a Mac. Maybe they're not, right? They could be a server sitting behind there. They're trying to mimic as much as possible to look like I'm a Mac, I have a normal browser, I should be allowed on the site, when they're actually automating some sort of attack. And we see things like tools out there that keep evolving, and a lot of the users or bad actors, excuse me, are using these tools like Puppeteer and Selenium. So all this coupled together helps these bad actors become more human-like. More and more attacks are happening on public portals. We kind of we kind of talked a little bit about that earlier, but anywhere there's value, anywhere there's value on a website, this is where the bad actors are going to be. If there's a benefits portal, say for example, unemployment benefits, that comes to mind right away. Bad actors, if they have their personal data, why wouldn't they try to extract that information and try to get access and try to get that, that benefit? Education portals, right? Grades are sitting there, financial records are sitting there. Those are very sensitive pieces of information, right? And no one wants a bad actor to be there. Our actual voting system, how we conduct, you know, our voting across the country is at risk as well. Uh, you could see things like, for example, denial of service attacks on voter registration or during the actual voting times, right? So things like this are very top of mind when it comes to bots. And la the last of the three is fraud, right? So fraud, when I think of fraud, a lot of times I think of, an account takeover type situation and maybe some sort of abuse post login. Again, some sensitive public data being protected behind a login, anything like that could be attacked in a fraudulent way. It tends to happen clearly behind an account, and usually I see like um, account takeovers being kind of that starting point. So we have to be able to watch for that fraud, not just at the point of login, but actually after the login itself and what's going on after that happens. Denial of service. Um, if if a bad actor wants to overwhelm a portal, like I go back to the voting system, right? That's also at risk. And scraping, of course, scraping, stealing public data, right? That's top of mind. Any PII or academic data could be stolen. Impact on users. We kind of touch a little bit on it, in the previous slide, but I'll go more in depth. It's important that all the websites are protected so that the users are, in essence, protected. Here are some more things that we can talk about around the impact that bots have on the public sector. Delayed access to services. System overloading could happen, right? Bots flooding the portals. You could see extended wait times, service interruptions. These are all things that can happen. And, you know, we have to we have to be thinking about how we can prevent these sort of things. The erosion of trust, in these systems. We all use public sector systems, right? We're all one society. So we need to protect these so that we have the public's trust in these systems. We can't have perceived insecurity, unfair experiences, loss of public confidence. These are all not good things. Cost, right? So not only will we not trust these systems if they're being attacked by bots, but we're also going to have cost impacts, right? That could yield just higher taxes because of these operational cost impacts and financial losses. Shifting gears a little bit, in today's, fast-paced digital world, securing these websites and services is critical, ensuring a smooth and safe and compliant digital experience for both citizens and employees. For example, you know, if we can protect these systems, we can boost performance, um, enable secure commerce, right? And then staying compliant, right? That's another key point. We have good compliance rules in place, like you have your GDPR, your CCPA, PCI. Good to stay compliant with those pieces and address um, any risk to the site. And of course, like we've talked about ad nauseum, preserving trust. So we've talked a lot about bots and some of the impacts they have, what they can do, why they're bad. Now let's kind of focus and shift gears on how we combat this bot activity. Combating bots is just not an easy thing for any organization. As I've discussed, these bots are more sophisticated. So the more sophisticated they are, the more human-like they appear, and thus the harder they are to detect. I'm going to pause here for a polling question. Every digital interaction is a potential target for a bot, whether it's a citizen logging into a government portal site, filling out a form, or completing a transaction. There's always someone or something looking to exploit it, right? So human sees the whole picture, connecting every interaction to catch these bad actors in real time, ensuring that the digital interaction engagement is secure and trustworthy. So we're talking all the way from digital services to application interactions to the sensitive transactions. So if you think about that, we're looking at things right um, at the client device, and in particular, we look at um, solving different use cases, right? So we have um, ads that we're protecting. We can protect against scraping attacks. We can help with PCI compliance, addressing any transaction abuse. Um, it's not on here, but we also have any automation on page, so we can help protect against SMS pumping, which I will discuss here later, as well as things that are happening post login. So you have account takeovers. We kind of talked about that a little bit. Not only do we protect at the login, but we can also protect post login and help preserve that human experience throughout the customer journey. So how do we detect and mitigate bots? It's really a multi-layered approach. We are a real-time monitoring solution, and we're looking for behaviors on the client device. So if, for example, a bad actor is trying to spoof that, we are looking for that. It's a game of a bit of cat and mouse, where we're looking for behaviors on the device. So if the mouse is moving at an exact 90-degree angle, we can detect that sort of behavior. If, for example, the characters being typed on the keyboard exceeds what's humanly possible during a session, that's another piece of information and behavior that we can analyze. We also do things like fingerprinting the device, and we are leveraging, client-side data. And like I said, it's a multi-layered approach here. So we are looking for other indicators as well. We find ways to rate limit and then also challenge this traffic. So the beauty of human is we try to decrease the amount of friction for real users. And we talked about that. It's really important that we only present challenges, sort of the capture replacement here on screen. You can see here, it's a simple click and hold for a user if they were to see or be challenged by human. It's a simple click and hold to exonerate. And I think that's key, where only suspected users, or excuse me, only suspected bot users would be challenged versus humans. So most humans will not, in other words, most humans will not see this challenge. In fact, we have a low false positive rate of typically 5 in 10,000 real humans would ever see the challenge. With human, you can protect your website. In summary, you're kind of ensuring that real humans are visiting. You enable your valuable resources to be preserved, and you're minimizing the risks and liabilities of exposure. You're basically keeping those bad actors on your website. Here, I want to show you a busy video, and just to kind of summarize before I play it, the spot is going to be building a Python-based bot, and it really opened my eyes to how fast and how easy it is for anyone, in fact, with zero training, to build such a bot. Um, it kind of opened my eyes to also like how pervasive and how in the future this could be getting even easier to do. So without further ado, let's play the video. Here you can kind of see, um, the prompt being displayed, and anyone could just type in kind of what they're looking for. And in this case, they're doing an API based attack. It's generating the content very quickly, and this Python script is being written. Um, from here, the attack could just be executed in a matter of minutes. In fact, as it spits it out, it even describes how the script works. So again, you do not have to be educated to and deep in knowledge on how to create a bot, but you could simply go on the web, go on an AI system like ChatGPT and generate it very quickly. Shifting gears, we're going to talk about a use case and some examples that I've helped solve. And I think I talked about it earlier, but I did solve an SMS pumping issue, and I'm going to talk about it here shortly. So here's a case study of stopping SMS pumping fraud. Let's start by defining what SMS pumping is. So SMS pumping is a type of fraud where an automated bot is exploiting an SMS service. In this case, it was, for two-factor authentication, but it could be anywhere where phone numbers are being inputted into a website, and it costs money for that SMS to be sent. So basically, there's some collusion with the the bot who is generating the phone number and the carrier who owns that phone number, and they get paid a specific amount of money for each time that text message goes out. So that's kind of at a very high level what SMS pumping is. So the challenge, right? So I had an organization who had enabled two-factor authentication, right? And that's very common to help protect, accounts. Well, over a weekend, they would see an attacker just spike and hit their API that does the SMS calls. So they would hit that phone number that they could gain what money for that telco provider. In fact, it drained over $15,000 worth of SMS messages over a weekend. So the solution to that problem was we put human in place and immediately stopped the malicious bot attacks. So we targeted and made sure that every time that SMS endpoint was called, that human was there. It allowed the human traffic through, so real users could still use the site, but it stopped those spikes and those automated attacks from happening. So $15,000, was just one weekend. This continued on over some time until they called us, and then we helped them step in and stop the fraud from happening. And they since haven't had that issue. So I know I'm talking about human. I want to talk about why human. So most security tools only cover, part of the attack surface. So they're leaving gaps where bad actors can exploit. Like for example, 2FA, and we talked about this a little bit earlier, but 2FA only addresses on a, you know, at the point of login, right? It doesn't protect after the login. So if a bad actor gets in, they still can use automation after the login. We talked about WAFs a bit, but WAFs block only known threats. They they cannot protect when think about that residential IP, right? That's a really good, residential proxies. That's why residential proxies have been leveraged, is that tooling gets past a WAF because it all looks like residential traffic, which is what a lot of websites will are looking for, right? They're looking for traffic from your Comcast, for example. And fraud detection tools um, focus on transactions but miss earlier signs of account takeover. So these gaps create blind spots, which make it easier for attackers, to bypass those defenses. So we at Human take a different approach, and we're monitoring, like we saw earlier, the entire digital journey. I'm going to leave you with a quote that I have that hopefully summarizes this presentation. Security and trust are not trade-offs. It's critical that they work hand in hand to ensure the mission success. I'm going to pause here for a polling question. In the slide deck here, I'll leave you with some additional resources as well. Next, let's talk about some common questions. So some of the common questions that I hear are, what are some future trends you predict for bots? Bots, I think, are here for the long haul. If you think about bots and what we just talked about, the technology for bots is improving as all other technology is. Bots are becoming more human-like, and that trend will continue. The bots we see today, are just the start of what they could be in the future. Now, you can't just think about what the bots are today, how they're evolving themselves. The access to the bots is also a concern, right? So when we think about bot trends, we can't just think about bot trends on the tech stack, but it's the availability of a bot. So if a bad actor, it could be maybe not it doesn't even have to be a group of people, right? It can be a single person. It can be someone who just wants to automate something for personal gain. Um, as you saw in the video, and I think that's why the video kind of is prudent to kind of show a bot can be created by just about anybody very easily. You don't need to know Python to generate a bot. In fact, if you didn't know how to run that bot, for example, or what any of that stuff meant, you could continue to ask AI and figure it out just with simple language. So, of course, these tools are meant for, hopefully used for good. But as you can see, someone can easily twist them and use them for nefarious activities. So, kind of in summary, what I see future trends for bots is I see a trend of more bots and a vast number of them, but I also see the technology improving as well. A second question that I get asked quite a bit is, what is the process for getting bot protection going? So in order to protect a site, it starts with understanding the tech stack. So many of many of the folks and organizations that I'm working with have varying degrees of technology that they're working with. Some, for example, some have WAFs, some are using CDNs, some are not. Some are using modern applications and frameworks. So, for example, some are using single page applications, building single page applications. Some are not. So, it starts with when it comes to getting protection in place, is understanding the tech stack. Starting point is there. So, that's the first thing that I'm interested in is understanding the tech stack. The second thing is that's maybe not looked at as, um, but it is important, is understanding the use case. And for me, it's understanding what the problem is that we're trying to solve. So getting bot protection is great, but really understanding why we're doing it, what's the reasoning is equally as important. So getting my arms around the use case as well. And when it comes to that use case, I really like to know what success looks like, kind of as a corollary of that. So getting to know what that use case is, whether it's a carding attack, a scraping attack that we're trying to solve, but then also understanding what does success look like? Because at the end of the day, some bots will get through, but we try to minimize that impact and hopefully yield the result that we're looking for. And to that end, and we kind of talked about it a little bit, that the tech stacks are different in on various organizations. Well, it's when I do understand the tech stack, then it really human really comes into play here and has a really nice website um, that describes how to integrate into these various platforms. One of the advantages of human is we are technology agnostic, and we really pride ourselves on that. What do I mean by that? So if you are using a CDN, for example, maybe you're using Akamai, maybe you're using Fastly, maybe you're using Cloudflare. We have integrations into those various tech stacks. Now, it's possible that you don't have a CDN, like one I've described. We can also solve the problem in other ways. We can install our technology at the application layer if necessary, or at the load balancer level. So there again, human is technology agnostic. And the various ways to install the tech is available on our website. So it's freely available. So do check it out at humansecurity.com. All right, let's shift gears into the next question that I commonly get. Is there an easy way to trial the human solution? Like, for example, a POC or a demo? And the simple answer is yes. So we have done various POCs with varying organizations. Commonly, we do a 30-day trial, and typically we get that install of the technology um, very early on in that POV process. Usually takes less than a day to install our tech. Um, One of the things to note is once the tech is installed, we can start providing insights. We run in typically a monitor mode state, which in essence means we're reporting on bots and we're not blocking them or stopping them until we change modes into what we call a mitigation mode. So it's very helpful for our organizations to see and our customers to see what the bots are doing first and then deciding how they want to stop them. So that process, again, is as a visibility process. We give you full access to our human console, which shows how the data with it shows in very visual format, the good bots that you're seeing. It shows the bad bots, it shows the human traffic, and it shows any crawlers that are on the site as well. It also shows any humans that solve the challenge, which I kind of showed in an earlier slide. On to the next of the common questions. How do we identify good bots versus bad bots? First and foremost, a good bot to some organizations are not necessarily a good bot to another. So we work with our customers to ensure that the bots are that are flagged are good versus bad. So the great thing about this is the counsel. It goes back to the human counsel again. Data is present in the counsel, and then we tend to walk through, say during a proof of concept, uh, the automation that we're seeing, and we have conversations with our customers to ensure that if we were to go into a mitigation mode, i.e., block the bots, then we're blocking truly the bad bots. Some examples of good bots, again, are some crawlers. Sometimes we see automated tooling that's doing health checking, for example, in production. So we want to ensure that that traffic is allowed through. That leads to the next of the common questions. How do we ensure we don't block the good bots? We have various mechanisms to do this activity. One is we recognize that the traffic may come in various ways. So for example, we have ways to identify the traffic via a header. We have ways to identify it via what ASN it's coming in from, IP addresses, what kind of paths are that are being used. User agent is another mechanism. So we leverage that information to help us create a rules engine and a policy so that that good traffic is allowed through. Now, it may be that that traffic might be hard to identify. We have other ways to add, I think I talked about headers just a little bit ago, but we can add a secret key, if you will, in a header value so that that is only shared from the good bot. So that is another mechanism we can use to ensure that only good bots are allowed through. So I think that the theme there is we have thought through many of these challenges, including how to identify those good and bad bots. The next of the common questions I get is, how do you do continuous monitoring? So the one the one way I would describe that continuous monitoring is we are monitoring that client device. So when your average user hits the website, they're running JavaScript in their browser so that that browser um, is is running some asynchronous um, tests in the background. We kind of talked about it earlier. We're looking for things like mouse moving at an exact 90-degree angle. We're looking for keyboard typing during a session. Is it humanly possible? We're looking for we have hundreds of tests that run during a given, um, throughout the life cycle of the viewing of the site. And during that time, we're continually running these tests. And that information is shared with our infrastructure to help score whether that's a human or not. So the continuous monitoring is continually happening. We're continuing to score this traffic to ensure that indeed the behavior on the client device, and I use that word intentionally, that behavior is indeed human behavior. So that's how we do continuous monitoring. Another common question is results of customers implementing human spot defense. We talked about this just moments ago, the SMS pumping. So regardless of the type of automation that's hitting the website, we can identify that traffic and prevent that automation from happening. I'll use some more examples. So were cases where there on one customer's website, there's a flow of information that goes from form to form to form to form. We sat in front of that traffic and stopped um, those forms from filling with data that is undesirable in that case. Um, we've seen cases, and I've seen cases and solved cases where a donation page, for example, a customer, this is where you have to really understand the customer and what challenges they're facing. So they had a carding attack on this particular website. This carding attack um, was causing them strain because their vendor was charging them for all the card testing that was happening. And so they wanted to stop this carding attack. So the challenge there was because this was an organization that was um, took donations, right? They couldn't afford any friction for their users. So adjustments needed to be made and really understanding the problem. Again, back to my earlier statement, understanding the problem was first in mind. And when we went through the process, we found and identified the traffic with the customer and decided to be very lenient on the detection because of that friction, right? Abandonment on a donation page will yield no con the user's not coming back. And so we found that happy medium. We added low friction at first, and then we turned up the detection until it was at the right level. So uh, as human, we were able to solve that problem as well. Um, Other cases of just generally scraping a site, scraping data. Now, I've solved that in various organizations, even at a pre-login and a post-login situation. The post-login was interesting because the user would log in as a real human and then start the automation. So keep that in mind. Human can stop, like we talked about earlier, that scraping from happening both pre and post login. So those are some quick examples of where human can really protect and some results that we've had. All right, last of the questions. What happens after you stop the bots initially? So some trends that we tend to see. A lot of times, this is all about incentives for bots. So even in the SMS pumping example, there's always a fear of the bots coming back, right? So what we tend to see when it comes to bots is we initially will stop the attack, right? And we'll see that spike in stopped traffic, bot traffic. And then there might be a lull. It might be a day, it might be a week, but the bots tend to retool. If there's incentive on any website, bots retool and then they come back. And so it is a game of cat and mouse, and we are ready for that time when they come back. So you may see some medium spikes there as the bots try to attempt to circumvent our detection. But ultimately, the bots are are stopped. You'll see that spike and that trend, and then you may see some minor spikes after. But having that protection in place and continually keeping that protection, even though you don't see the perceived spikes that you would want, you want to see that spike that it's a point of, victory, if you will, to stop the bots. But at the end of the day, the spike the initial spike and the stop will tend to have a downward trend in terms of bot activity with minor spikes after. But the one thing I will remind folks is keep the bot protection in place as a preventative measure because if you take it away because you have lower bot traffic, that does not mean I mean that invites them back in and they will find their way back in. Thank you everyone for the time today. It was a pleasure to speak to you. Please do reach out to us if you have any questions. We'd be more than happy to help you.